The PCB Editor Skill API includes a set of Axle form functions that allow you to create forms, just like the forms you see in the PCB editor. Your forms can then be used to interact with and retrieve information from the user. The form mechanism begins with the creating of a form definition file, an ASCII text file that defines the form and all the fields in the form. We will also need to define a skill callback function that will control how the form behaves. We can create the form in memory with a single skill function, and then display the form on the screen with a second skill function. Once the form has been displayed, a loop will automatically run where our callback function is run every time the user changes data in the form. This loop will continue until you programmatically end the loop, usually when the user selects OK or Cancel in the form. In a previous training byte, we created a function that reports wicked small segments. It asks the user if DRCs should be added to the segments, and the aspect ratio that determined what a wicked short segment is. Rather than repetitively asking the user for information, we will create a form, so all the information is entered in a single go. Let's start by creating our form definition file. The form definition file is a plain ASCII text file and generally has a form file extension. Syntactically, the form has to start with file_type equals form_def version equals 2. All the fields of our form are defined between the form and the end form keyword, and you can only create fixed forms with skill, which means the size of the form does not change once it is displayed. The port keyword will define the size of our fixed form, and will make ours 55 characters wide by 15 lines tall. The header keyword requires a string that will be the title displayed on our form once it is displayed. Most forms only have a single tile, so all of our fields will be between the tile and an end tile keyword, and we're now ready to define the fields and text in our form. Text in a form has no programmatic meaning, but it indicates to the user what each field is for. It starts with the text keyword and the string that should be displayed in the form, and then the tloc keyword to define the location of the text. The X location is defined in characters, and the Y location is defined in lines, with the origin of the form being the upper left corner of the form. We'll have text for our fill-in field, for entering the aspect ratio, but buttons, checkboxes, and radio buttons have text defined with the widget, so that is all the text we need to add. Now we define the fields of our form. Fields start with the field keyword, followed by the name of the field, and end with the end field keyword. The floc keyword defines the location of the field in the form, and we're creating a fill-in field that will be displayed at 4 characters wide, and will only allow the user to enter up to 4 characters. Our fill-in field has to be a number, so we'll use the real fill-in keyword, so we do not have to do any error checking. The form will make sure that the user only enters a number. We'll have a field named DRCs at location 54. That will be a checklist, and we'll display the text Add DRCs to the right of the checklist. Finally, we'll have an OK button and a Cancel button in our form, so we'll create a field named OK and define its location. It will be a menu button that displays the string OK, and the button will be 10 characters wide and 3 lines high. We'll also create a field named Cancel for a Cancel button, and our form definition file is complete. Next, we need to define the callback function that will automatically be run each time the user changes to a new field in our form. The callback function must accept exactly one argument, and this will be the skill data structure that defines the current state of the form. The form data structure will always have a field titled Members that will return a list of the name of all the fields in the form. The cur field member will always return the name of the field that last changed in the form, and the cur value member will always return the value of the current field. The callback function is often just a big case function, with a different branch for each field in the form. The field names are defined in our form definition file, and when a user enters or changes fields, our callback function is automatically run. So when the user changes the ratio field, we would like to make sure the user entered a number between 0 and 1. So we can use the cur value member of the form structure to check the value, and when it's not between 0 and 1, we will set the field back to its previous value with the Axle form restore field function. The DRCs field is a Boolean checkbox, so we do not need to do anything when the user changes this field. When the OK button is pressed, we need to do a couple of things. We will first get the value of the ratio field and the DRCs field using the Axel form getField function. We can then run our rpt small segs function and pass it the value of the ratio and the DRCs flag. If you watched our previous training byte, you may realize that our rpt small segs function needs to be modified to accept the two arguments and to also remove the functions that currently ask the user for the ratio and the DRCs. Let's pass the two arguments, remove the prompts, and we can also remove the validating since the form is doing that for us for free. Back in our callback function, we also want to close the form in our OK branch using the Axel form close function. Finally, our cancel button should close the form without running our rpt small segs function. The last thing we need is a function to get the whole thing rolling. Let's create a function named small segs start. When run, it needs to create and display the form that we defined by using the Axel form create and the Axel form display functions. The Axel form create function accepts a variable name that will store the form structure, the name of the form definition text file that defines the fields in the form, the location of the form when displayed, a symbol with the name of the callback function for the form that will run each time the user changes a field in the form, and a flag of T or nil to determine if our form will block other PCB editor interaction while the form is open. We'll use nil to make it a blocking form. This creates the form, and we display the form with the Axel form display function, passing the structure of the form. Before we display the form, we can set a default value for the ratio field using the Axel form set field command. Now, when the small segs start function is run, the form is created, the form is displayed, and the callback function will run every time the user changes a field in the form. Let's save, load, and run our function, small segs start, and we see our form opens. We can toggle the DRC button, and when we select OK, we are prompted to select our area and our small segments are reported. In summary, the PCB Editor Skill API includes a set of Axel form functions that allow you to create forms just like the forms you see in the PCB editor. Your forms can then be used to interact with and retrieve information from the user.